In the next problem here, we have been given what we call a relative frequency distribution. And in these types of distributions, what we're looking at more is the percentage of data points that are falling in our different groups that we have. Because sometimes when we have a lot of data, it's not exactly as important to know the number of data points that are in each group range that we have, but instead the percentage of them that are in that range compared to everything else. So in this problem, we have been given a relative frequency histogram below of our test scores. And with this, we are going to assume that the number of people that took this test, the test scores that we have, is 572. So 572 people took some exam, and their test scores were then used to create this relative frequency histogram. And now I want to use this to create the frequency distribution table over here on the right. So that means I need to figure out what the score ranges are that they used, the relative frequency, and then we can calculate the frequency from that. So if we take a look at the histogram, we have our scores on the x-axis and the relative frequency along the y-axis. And then we can also see the bars that are on this graph here. So if we take a look, it looks like that first bar is going from 20 to 30. So that would be the score range that they used for that. And the height of that bar appears to be at about 10. So I would say the relative frequency would be 10%. And then the actual frequency, if I want to then calculate that, well, we know that there was 572 people that took the exam. All we have to do is multiply that by 10%, but in the decimal format, which is 0.1. That gives us 57.2. So I'm just going to round that down to 57 people. Probably got a score between 20 and 30. The next ranges that we have on here, we need to continue to go up in tens because we like our class sizes to all be the same. So we would have 30 to 40, 40 to 50, 50 to 60, and 60 to 70, then 70 to 80, 80 to 90, and lastly 90 to 100. And now for the next four ranges on here, we don't have a bar. It's completely flat from 30 to 70. So that means this relative frequency would be 0% for each of those. And now if 0% of the people got a score in those ranges, well then the frequency would just be 0. So if we take 0% times 572, that will be 0. Okay, next 70 to 80, that region, we can take a look at that bar and figure out the height of that looks to be at about 20 over here on the left. So that would be about 20%. And then 20% times 572 gives us 114.4. So I'm just going to round that down to 114. Next, we have 80 to 90. So this bar, it's our tallest one on the histogram. And if we go over to the draw a line over to the relative frequency, we see that it's at about 40%. So now our frequency, 0.4 times 572, gives us 228.8. So I'm just going to round that up to 229 for the number of people. And then lastly, our last bar here from 90 to 100. And if we draw over to that, we can see that it's at about a height of 30. So this would be 30%. And now for the frequency for that one, 0.3 times 572. Round that up, and we should get 172 for the number of people in that region. And then one last thing about this, depending on your rounding of the frequency, if you add all of those together, in this case are 57, 114, 229, and 172, you should get pretty close to the number that was used to represent this histogram, that 572. It might be a little bit off depending on rounding, if you're routinely rounding up or routinely rounding down for all of them. It could be off by a little, but it should be pretty close, if not exact.